Hello students, welcome to IE. In this session, we are going to discuss about the basic theory of current mirror circuit. So let's go for that. So the name current mirror circuit. So what does it mean? So the current mirror circuit, the basic definition of the current mirror circuit gives like this: a circuit whose output current will be the mirror image of the input current. So that means if we draw a block diagram, suppose this is a block diagram of current mirror circuit. We are representing the current mirror circuit using a block diagram, and let us name this current mirror circuit CMC, in short form current mirror circuit. So it will be the input of the circuit and this is the output of the circuit. So in the output we will get a current I out. Similarly, in the input we will have a current I input. So according to the definition of the current mirror circuit, we can say that this output current will be the mirror image of the input current. Then only this circuit will be called as the current mirror circuit. So now this was the definition of the current mirror circuit. So what will be the actual circuitry inside this block diagram? So to understand that, let's first take this example. This is the first circuit. So this is the circuit number 1. Suppose this is circuit number 1. So in this circuit number 1, you can see there is an NPN transistor. So in the NPN transistor, the first thing that we denote here, what are the terminals here? So first terminal is, this is the emitter terminal, this is the base terminal, and this is the collector terminal, you can see. And the base and the collector are short circuited. The base and the collector are short circuited. So we can say from this that the voltage across the collector to base, VCB. So VCB will be 0 here. So if the VCB will be 0, then the junction between the collector and the base, that is the JC junction, this JC junction will be the reverse bias. So JC junction आपका यहाँ पे होंगे, JC. So this JC junction के लिए मेरा VCB 0 हो रहा है. So that means the JC junction, that is the collector junction, will be reverse bias. So this is the first information that we can extract from this circuit. Now let us take the current. So it is an NPN transistor. So this is the N, this is P, this is N. So NPN transistor में मेरा क्या होता है कि ये जो current होंगे, this will be the IE current which will be in the outward direction. Similarly, the base current will be in the inward direction. So here I will get the base current. Similarly, I will get the collector current. So collector current will be in the inward direction, base current in the inward, and IE in the outward direction. And this IE current can be written as, IE is equals to IB plus IC. So this is the current information that we can get right now. Now another thing we can see, ये जो मेरा base to emitter voltage है. So base, ये मेरा NPN transistor है. So NPN transistor में क्या होता है? Base will be at higher potential than the emitter. So that means the potential across the base and emitter, this will be positive, this will be negative, and this potential is VBE. And base will be at higher potential than emitter because it is an NPN transistor. So these are the information that we can get right now, you can see. So now, ये जो पहला सर्किट है, इसमें मैंने क्या देखा था कि मेरा कलेक्टर और बेस यहाँ पे शॉर्ट सर्किट है. Another thing we can see, if it is short circuited, यहाँ पे अगर शॉर्ट सर्किट होता है, तो ये जो बेस कलेक्टर टू बेस पोटेंशियल है तो 0 है, इसीलिए मेरा जंक्शन, कैपेसिटर जंक्शन आपका फॉरवर्ड बायस हुआ था. अब now we can see, let us see that. So from this circuit what we can see that if I can write IE equals to IB plus IC, ये मैंने देखा था. अब let us assume that ये जो बीटा है, ये सर्किट का जो बीटा होगा, that means ये जो ट्रांजिस्टर है, NPN ट्रांजिस्टर, इसका जो बीटा है, let us assume that बीटा is infinite. So if beta is infinite, so what will happen? So if beta is infinite, then we know that IC is equals to beta into IB. And what will be the IB here? So IB will be IC by beta. So if beta is infinite, then IB will be 0. If it is infinite, then IB will be 0. So that means when we assume that beta is infinite, then we can write that IB will be nearly equals to 0. So from this equation, what we can say that IE, that is the emitter current. So emitter current will be 0 plus IC, that means only IC. So IE will be equals to IC. Now, what will be this IC? According to the ट्रांजिस्टर एनपीएन ट्रांजिस्टर आईसी का एक इक्वेशन होता है. सो आईसी का जो इक्वेशन होंगे दैट विल बी आईसी इज इक्वल्स टू आई जीरो एक्सपोनेंशियल वीबीई डिवाइडेड बाय वीटी. सो व्हाट इज आई जीरो? आई जीरो क्या होगा? आई जीरो इज द रिवर्स सैचुरेशन करंट ऑफ द एनपीएन ट्रांजिस्टर and VBE this potential and VT this the thermal voltage. So if I put this equation in this place, so what will be the value? So ये वाले equation में IC में put करूँगा. So if it can be written as I is equals to I0 into exponential VBE divided by VT. This will be the equation. Now from this equation you can see यहाँ से I can see that ये जो मेरा I reference current, this is the I reference current source. So if this is the I reference current, so this IE current will also be this I reference, because यहाँ पे I reference current आके यहाँ पे आपका divide हो सकता है parallel. Again it will become inside the transistor, then it will become IE. So IE and I reference current will be same. So that means we can say that this IE current is nothing but the I reference current. I reference current. So exponential VBE divided by VT. Now from this equation, if we want to find the value of VBE, then what will be the value? So I can write it as, it will be exponential VBE divided by VT is equals to I reference current divided by I0, and I0 was the reverse saturation current of the transistor, NPN transistor. So if we take ln on the both side, if we take ln, then I can write it as VBE is equals to VT ln I reference divided by I0. So this is the equation of VBE we have got from this transistor. ये transistor circuit के लिए मेरा VBE का relation आया. VBE is equals to VT ln I reference by I0, and I reference was the current that we have, current source that we have connected here. Now ये था पहला वाला circuit. Now let us take the second circuit. This is the circuit number 2. So if it is the circuit number 2, so in this circuit number 2, there is also a NPN transistor. So if it is an NPN transistor, so this is N, this is P, this is N. So first thing kya? First let us denote the terminals. So this is the emitter terminal, this is the base terminal, and this one is the collector terminal. Now let us see the current directions. Since it is the NPN transistor, so the IB current will be in the inward direction, IC current will also be in the inward direction, and IE will be in the outward direction, and this IE can be written as IB plus IC. So this is the current that we have found. Another thing, since it is an NPN transistor, so the voltage drop across the base to emitter can be written as VBE. So this is the voltage and the current inside this first circuit. Now let us see, यहाँ पे मैंने जो करंट का इक्वेशन डाला था, सेम इक्वेशन यहाँ पे डाल सकते हैं. क्या डाल सकते हैं? कि यहाँ पे मेरा जो I इक्वल्स टू IB प्लस IC था, सो इन दिस इक्वेशन यू कैन सी ये जो IC करंट है, कलेक्टर करंट, this current is nothing but the output current, I out. I can write it. So I out is equals to IC. So I can write that I out is equals to IC. Similarly, it is an NPN transistor. तो IC का करंट का इक्वेशन क्या होंगे? दिस टाइप का इक्वेशन आएगा, सेम इक्वेशन. सो यहां पे भी मेरा सेम इक्वेशन आएंगे, I0 एक्सपोनेंशियल V BE डिवाइडेड बाय VT. I0 क्या है? ये I0 आपका ये ट्रांजिस्टर का रिवर्स सैचुरेशन करंट. दिस ट्रांजिस्टर, सपोज आई नेम दिस ट्रांजिस्टर एज Q2 and suppose I name this transistor as Q1. So this I0 is the Q2 transistor's reverse saturation current. This VB is this VB voltage. VT is the thermal voltage here. So now from this equation, if I want to find the value of VB, so VB value क्या आएंगे? I am writing directly. So after taking the natural logarithm, what will be the value of VB? So VB can be written as VT ln I out divided by I0. So this will be the equation of VBE for this Q2 transistor, and this is the equation for VBE for this Q1 transistor. Now the story comes, यहाँ पे मेरा Q2 है, यहाँ पे मेरा Q1 है, इसके लिए VBE है, इसके लिए VB है. Now if we assume that the Q2 transistor and the Q1 transistor has the same value of beta and same value of VB, then what will happen? So if these two transistors Q1 and Q2 will have same value of VB, then what will happen? So मैं लिख रहा हूं कि if we are assuming that if the VBE value of Q1 and Q2 are same, if they are same, then what will happen? Then this equation, ये वाला equation आपका इस equation के साथ same होगा. So that means we can write that VT ln I reference by I0. So VT ln I reference by I0 will be equals to VT ln I out by I0. Okay, so this is the equation right now. So that means from the left hand side and right hand side we can see that VT and VT will cut down. If we take exponential on the both side, then we will get I reference divided by I0. It will be IZ out divided by I0. Now what is I0 and what is I0? This I0 is the reverse saturation current of Q2 and this I0 is the reverse saturation current of Q1. So ये Q1 का reverse saturation current है और ये Q2 का reverse saturation current है. So अगर मेरा I0 भी same होता है Q1 और Q2 के लिए, so I can write that I reference will be equals to I out. We can get right this. That means ये जो I out current होंगे ये I reference current के साथ same होगा. So you can see that the output current will be similar to the reference current. Then what will be done? Now let us combine these two circuits. If I combine these two circuits, then we can draw the circuit like this. Suppose ये वाले सर्किट को मैं पहले ड्रॉ करता हूं, तो यहां पे मेरा Q2 ट्रांजिस्टर NPN like this, and ये वाले सर्किट को यहां पे ड्रॉ करूंगा. So that means यहां पे मेरा I reference, this is I reference, उसके साथ मेरा एक NPN ट्रांजिस्टर इस तरीके का, इसको मैं ग्राउंड कर रहा हूं. ओके, एंड यहां पे मेरा बेस टर्मिनल और कलेक्टर और बेस टर्मिनल शॉर्ट सर्किटेड. अब ये दोनों टर्मिनल को मैं कनेक्ट कर रहा हूं ऐसे, और यहां पे मेरा कलेक्टर टर्मिनल है, ये कलेक्टर। नाउ दिस इज द Q1. अब दिस इज इन दिस वे वी कैन कॉम्बाइन दिस टू सर्किट्स Q1 एंड Q2. अब देखो यहां पे मेरा I out आ रहा था, so this was the I out. अब if the and the potential of Q1 at the base to emitter, यहां पे बेस था, यहां पे एमिटर था, so this potential was VBE1 suppose, and this two potential is VBE2. suppose I am defining two potential VBE1, यहां पे मैंने VBE1 और VBE2 को सेम माना था, तो मेरा I reference इक्वल्स टू I out आया। अब मैंने क्या किया, दोनों सर्किट को कंबाइन करके यहां पे VBE1 और VBE2 लिखा। अब देखो यहां पे मेरा बेस है, यहां पे मेरा बेस है, यहां पे कलेक्टर, यहां पे एमिटर, यहां पे भी मेरा कलेक्टर, यहां पे मेरा एमिटर, यहां पे बेस। सो अब देखो ये जो सर्किट है, इस सर्किट में मैं अगर ये वाले लूप के अंदर केवीएल अप्लाई करूंगा, ये वाले लूप के अंदर, मतलब इन दिस डायरेक्शन, इफ आई अप्लाई केवीएल, so if I apply KVL here, so what will be the KVL equation? The KVL equation will be, यहां से अगर स्टार्ट करता हूं, यहां पे मेरा बेस है, यहां पे बेस, so if I start from this direction, तो यहां पे क्या है, नेगेटिव पोटेंशियल, यहां पे पॉजिटिव पोटेंशियल, so नेगेटिव VB1, so नेगेटिव VBE1, यहां पे क्या है, प्लस, यहां पे माइनस, तो प्लस VBE2, so प्लस VBE2 is equals to 0. So that means we can see that VBE1 is equals to VBE2. That is two base to emitter potential, यहाँ पे base to emitter potential दोनों सेम है, इसीलिए मैंने यहाँ पे VBE को Q1 और Q2 के लिए सेम माना था। So that means मेरा VBE1 और VBE2 अगर सेम हो जाते हैं, तो ये जो I out होंगे, this I out will be I reference, because we have already proved that. So in this way we can form the basic structure of a current mirror circuit. So in this is the basic structure of a current mirror circuit, where this Q1 and Q2 will be identically matched. ये identical match होना चाहिए Q1 और Q2 को, मतलब ये दोनों का बीटा सेम होना चाहिए, दोनों का VB सेम होना चाहिए, दोनों का IC सेम होना चाहिए, दोनों का आपका I0 भी सेम होना चाहिए, तभी तो ये I0 और ये I0 कट आउट होंगे। So that means the basic requirement of the current mirror circuit has different points. The first point is that if I write down here, I am writing here. So the first point we can see that this Q1 and Q2. So Q1 and Q2 जो होंगे, that Q1 and Q2 should be identically matched. So we can see that this is the basic current mirror circuit. And what are the basic requirement that this circuit will behave as a current mirror circuit? So the first requirement that we can see is the first requirement. The first requirement that this Q1 and this Q2 must be operated in the active region. So that means Q1 and Q2 must be operated in active region. एक्टिव रीजन में दोनों को होना चाहिए, तभी ये वाला सर्किट आपका करंट मिरर सर्किट होंगे। अगर एक्टिव रीजन में नहीं होगा, देन वी कैन नॉट यूज दिस फॉर्मूला। ये सिर्फ एक्टिव रीजन में ही काम आता है, IC इक्वल्स टू बीटा IB। तो इफ आई एम यूजिंग दिस फॉर्मूला, देन दैट मीन्स दिस Q1 and Q2 मस्ट बी इन द एक्टिव रीजन। दिस इज द फर्स्ट रिक्वायरमेंट that this circuit to be the current mirror circuit. Next, the second point. What is the second requirement? The second requirement is that the Q1 and Q2 transistors should be identically matched. So Q1 and Q2 should be identically matched. So what is the meaning of identically matched? First we have to learn that. So the identically matched transistors मतलब होता है कि मेरा जो VBE है, that is the VBE1. So VBE1 should be equals to VBE2 and IC1 should be equals to IC2. Beta 1 should be equals to beta 2 and the reverse saturation current of the Q1 transistor, reverse saturation current of Q1 transistor should be equals to reverse saturation current of Q2 transistor. Then only we can cut this I0. If this I0 and this I0 are not equal, then how can we cut down? How can we cancel this from the right hand side and left hand side? Since we have cancelled out these I0s, that means आपका Q1 transistor में जो reverse saturation current होंगे, that should be equals to the reverse saturation current of this Q2. Otherwise, we cannot cancel out this. So this is the second requirement that will be required for this circuit to be a current mirror circuit. Now suppose if let us assume that ये जो Q2 है, ये जो Q1 है, इसका जो रिवर्स सैचुरेशन करंट है, ये दोनों इक्वल नहीं होगा तो क्या होता है? So let us see that. So for that purpose, let us assume that let the I0 value of Q1 is 2 times of I0 value of Q2. If it happens, then what will happen? Then we cannot cut this, we cannot cancel this I0. So that means our equation आपका जो आएंगे तभी आपका यहाँ पे आएंगे I0 of Q1 and this is equals to I out divided by I0 of Q2. So this I0 of Q1 is equals to 2 of I0 of Q2. So that means we can write I reference divided by यहाँ पे 2 आ जाएगा और यहाँ पे आ जाएंगे I out. So that means we can say it will be I out will be I reference by 2. So I reference by 2. So दोनों इक्वल नहीं हो रहा है, मिरर इमेज नहीं हो रहा है. So मिरर इमेज होने के लिए आपका दोनों ट्रांजिस्टर का जो रिवर्स सैचुरेशन करंट होंगे दोनों सेम होंगे. Another thing to note down, another important thing, this reverse saturation current I0 किसके ऊपर डिपेंड करते हैं ट्रांजिस्टर में? Actually, the reverse saturation current of a transistor depends on the emitter junction area. Emitter junction का जो एरिया होता है उसके ऊपर मेरा ये I0 डिपेंड होता है. That means ये जो I0 है, that is the reverse saturation current of Q1 and Q2 तो दोनों सेम होना चाहिए. अब let us see on what factors the I0 of a transistor depends. And basically, the reverse saturation current of any transistor, of any NPN PNP transistor is proportional to the junction area of emitter. Emitter junction area के ऊपर डिपेंड करते हैं और प्रोपोर्शनल होते हैं. So that means if I denote the junction area as AE, suppose AE is the junction area of the emitter, then what will happen? So I0 of Q1 transistor will be proportional to the junction area or emitter junction area of the Q1 transistor. Similarly, the I0 of Q2 transistor will be proportional to the emitter junction area of this Q2 transistor. What is the requirement? Requirement is that the I0 of Q1 and I0 of Q2 should be same. So if the I0 of Q1 and Q2 is same, then we should find that the junction emitter area of the Q1 transistor and the junction emitter area of the Q2 transistor should be equal. So that means AE of Q1 transistor should be equals to AE of Q2 transistor. If it happens, then only I can say that the I0 of Q1 and I0 of Q2 will be equal. So the basic requirement is that the junction area of the Q1 transistor should be equals to the junction area of the Q2 transistor. And this is very important because ये junction area के ऊपर depend करते हुए, if you look at the previous years, then for a current mirror circuit question आया हुआ है. So junction area आपको दिमाग में होना चाहिए कि junction area of the two transistors अगर same होंगे तो उसके लिए मेरा जो रिवर्स सैचुरेशन करंट होगा ट्रांजिस्टर का वो दोनों सेम होंगे. सो दिस इज द रिक्वायरमेंट्स ऑफ अ बेसिक करंट मिरर सर्किट. द फर्स्ट वन वाज द एक्टिव रीजन में होना चाहिए, देन आइडेंटिकली मैच होना चाहिए, और एक था कि मेरा जो एमीटर जंक्शन एरिया होता है दैट एमीटर जंक्शन एरिया ऑफ द टू ट्रांजिस्टर्स Q1 एंड Q2 दोनों का सेम होना चाहिए. सो these were the basic requirement of this circuit to be operated as a current mirror circuit.